Hi everyone, good morning, good afternoon, good evening, wherever you are joining me from. Today's session is about AI enhanced DevSecOps. Now, DevSecOps is something which we have been speaking for a very, very long time. And now, when we are talking about AI, we are adding AI or LLMs, or there are multiple other terms which are there. We are adding it to anything and everything that we talk about. So without further ado, we'll get to it. This is my perspective, completely my own perspective. Everyone has their own perspective about AI, DevSecOps, and especially AI enhanced DevSecOps. So if you think that there's something which you know better than me, please feel free to share your feedback, share it with me. I'll share my LinkedIn as well. I'll be happy to connect with you over LinkedIn. And it's a continuous learning that we have. So if I say I know everything, no, I don't know everything. It's a learning process. So if you have something new, some story to share, I'll be happy to learn from you and be part of the journey which is there. Now, let's get started without further ado. A little bit about myself. I am Vandana and I'm currently working with Snyk, and I'm taking care of things across Asia Pacific. Apart from that, I've also served on OWASP Global Board. I was there for 4 years as a tenure, as part of my tenure, and apart from that, I'm serving on the Black Hat Review Board. Now, that's about me. Now, let's get on the topic. Now, we will build a story as if we are very new to it. Especially when we talk about AI, everyone thinks that this is something which we are adding new to it. Now, every application, like nearly every application, is powered by ML models or agentic services, or what we call it as AI as well. And AI is not just an add on, it's the core intelligence layer behind all the business logic that we have. We are recommending systems which are tuning themselves instantly. There are fraud engines which are learning and adapting in the real times. There are customer support agents which are resolving issues without even human interactions. So like your customer relationship management tools, what CRMs, inventory engines, HR platforms, all have AI co-pilots running behind the scenes. Whether it's for reasoning, whether it's for predicting or optimizing the things. Now, at the same time, there are systems which talk to each other through natural language interactions or autonomous things. APIs are evolving into agent to agent conversation. I think that's something which I totally love, where data plus intent move freely using natural languages instead of like those rigid schemas that we used to have. We have billing agents which are retrieving overdue accounts and negotiating payment extensions with the CRM systems. That was very new to me. And like, how come somebody is actually getting the old dues and trying to negotiate that, can you, this the final amount that you can pay, and clear that. There's no pre-programmed flows, no brittle integrations, just intelligent cooperation. So think of it like a sales agent which asks the financial agent for real-time customer risk scores. Now, this becomes even interesting when AI becomes the backbone of software creation. Now, AI dramatically accelerates, and if you see that there are a lot of organizations which are generating the code using AI or LLM, they're testing, they're documenting, like there are README files which are being created using AI. Then there are security reviews which are being done using AI. Human shift is happening from writing code to setting intent, defining guardrails, reviewing the outcomes, where a product manager now decides a new feature in plain English. An AI agent which builds the API, write the test, generate the documents, deploy it to staging, even perform security validation. So there's like submitting a pull request with full traceability. Human just have to approve it. But that's where human comes into picture. So if we think about that, these are the things which are there. What are the key challenges, key barriers which we are still facing? Because there are a lot of key barriers which are there. Whether we talk about different toolings which are there, because with these barriers, I think we also need to understand that we need to start working towards a place where we understand whether these legacy security can slow down the development, or are we trying to overwhelm the developers, or we're trying to automate everything, saying that, oh, AI is there, let's automate everything. So these are some things which are still we are trying to scale across. But it's not just stopping here, because the problem is we need to understand that what are the things, where are the things, and how are the things which we are trying to achieve, whether we are building the product, whether we are trying to understand where things can go wrong. So security is an afterthought when we talk about tech revolutions. That has been the case for a very, very long time. But when we talk about AI, history is repeating itself. Every time we accelerate technology, we bolt security on later. Now we're talking about AI, we are building everything, but when we talk about security, at times I feel, yes, it's instead of just adding security by design, we're trying to build just the building things. So, and every time the result is the same: breaches, panic, retrofit, or compliance catch-ups. Talk about those API keys which are floating, open API keys which are floating on GitHub. That's there. Whose mistake is that? No one's. But we want to build fast, but at the same time we are compromising on security. Now let's walk through the pattern. We talked about digital transformation. We wanted to move fast, but we will secure later. What happened? Organization which raced toward digitize, and I think most of us did it. Banking wanted to do online services, retail wanted to do e-commerce, healthcare digital patient systems, but security lagged behind. There are hard-coded credentials, weak access controls, no data classification. I think data classification has been a big barrier since the day we have started talking about classification. Still, I think there's no proper information around it. Little to no encryption that we talk about. And then what we see is that waves of data breaches. PCI rushed into existence. Vendors which are scrambling to patch legacy systems. Now, these standards which are here, they're not just like a checklist. They're here to tell us that these are the things that can go wrong. So we need to, if we start taking things diligently, I think half of the things will be fine there itself. So innovation comes first. But what has been the case, security caught up only after attackers forced the issues. It took another 600 days to secure it. Can we say that? Absolutely, that's the thing. Now, when we were catching up with digital transformation, then came cloud adoption. Lift and shift and hope for the best. What goes now? Or then what happened? Everyone rushed to public cloud, whether it's AWS, Azure, GCP, everyone. I love all the three clouds, to be honest. I'm using it. Infrastructure moved from on-premise to dynamic services. But security teams were not even ready for it. There were misconfigured S3 buckets, public data was everywhere, there were flat IAM roles, over permissions user which were there, shared secrets everywhere. When you can't when you can't save your secret, who can save it? Then we started talking about zero trust model that nobody is following. Then came open cloud security buckets, cloud storage buckets. There were misconfigured IAMs. We saw a lot of attacks around it. Lack of cloud governance, which is still the case. Many organizations have still those issues. And due to that, there was another term that came into existence, which was cloud security posture management. And that emerged after the problem was widespread. So we moved everything to the cloud before learning how to lock the doors. We just wanted to move there. And it's not a leak. We just accidentally shared our like all those S3 buckets into the entire planet. And there are attackers who are there to just monitor that whose S3 bucket is open. Now, that's just an example around it, but there are multiple things which are widespread open. Now it's an AI revolution where let's shift fast, and then we'll fix those prompts later. Now it's just plain English, where we are trying to converse with our AI models or LLM models or agents that are there. So AI models are being integrated everywhere, whether it's apps, whether it's workflows, business logic, agents taking actions. But security is again behind. No governance or prompts or model on no governance on prompts or the models which are there. There are the sensitive data which is exposed to LLMs. Now LLMs are like parrots. If you give them if you give them that kind of a data, they'll remember it. Whether you use it or not, they might share it by mistake with someone else, or maybe in some context which you wouldn't want. Then came AI generated code, which is often insecure, because till the time you don't give the right prompt, how will it know that I have to secure it? It'll give you the plain thing which you want. There's no monitoring on agent behavior. Then we talk about shadow AI everywhere. So we are just opening new attack surface, and whether it's prompt injection, whether it's model poisoning, data leakage, there are unauthorized actions which are there, AI generated vulnerabilities which are there. So we talk about regulations, we talk about standards which are coming after we have deployed it, and it's still in under talks, just like cloud. So we are repeating the history, building capability first, guardrails we are building later. What we need to do is, I think we're still late, and we need to understand how does this evolution is happening. And especially if I talk about DevSecOps, I need to talk about AppSec. So here we talked about legacy SDLC, then we talked about DevOps. Now we started talking about developer security, and then we talked about AI native development. Then came the issues. Like AI is actually changing how apps are being built and created. Now, look at these stats. What does these stats say? That 95%, like by 2030, 95% of the code will be completely generated by AI. That's a huge amount of code, and that's something which is like given by Microsoft CTO Kevin Scott. Now, it's a hypothetical thing, but it may be even more. Think of that situation, that how are we going to handle that amount of code? We are talking about that somebody has written the legacy code and we don't know where we are heading. Now we're talking about speed plus scale, and then it becomes elevated risk. When most code results from AI security, we need to attempt or adapt at machine scale or machine pace. Can we do that? I don't think so. We've been talking about, oh, somebody wrote the code, we don't know how to use it. Now here machine is writing code and we have no clue where we are heading. Then comes a point that this AI generated code. Now if you see what Gartner has written, 48% of AI generated code contains security vulnerabilities. And now that's like the research which is done. And by the time we hit 2030, how much amount of code that we will see which has security issues? Maybe less, maybe more. And that's something to talk about. And yet, most enterprises have no trust control policies or technical guardrails in place which govern this AI-driven development. So what shall we do? If that AI-generated code has 50% chance of risk and is deploying without review, or there will be vulnerabilities that might skyrocket. So what will you do in that case? And meanwhile, while we talk about no policies, then it becomes even the more issue. Now talk about why AppSec must evolve in the age of AI. For years, application security or AppSec, what we call it as, has operated like a gatekeeper in the end of the deployment or development. Now here we are writing the cases, we are building it, we are testing it, we are finding issues, we are fixing it, and then we are releasing it. Traditional AppSec, which is like the last step of it, like right after what we call it as fixing. And then we're like, oh, these are the things which are there. And then everything speeds up. Oh, there are critical issues. What should I do? Where should I go? And that's where these whole issues we need to address as early as possible. Now we have dev cycles which are very short. There are cloud native architecture which are exploded. Earlier we used to release in like years. I remember doing the release after 6 months. Now can we say that? Now we can't even say 2 months. We can't even say 1 month. We can't even say 1 week. There are releases in day. in just a day. So how would you deal with that? And here CI/CD pipeline now push multiple releases daily. Code bases have grown drastically. There are new features which are coming up like lightning. So these third-party dependencies and open source usage is again skyrocketed. So that while we talk about faster delivery, there's more complexity, there's larger attack surface. It became nearly impossible for traditional AppSec teams to manually review every commit or dependency or model or container or configuration. Let me tell you, when I started off personally, I remember doing those manual code reviews. There was no such tool which was like, oh, doing code reviews. There were some tools here and there, but nothing like concrete which we can use. And it was not something which was a private priority to do the code reviews. And now, while we talk about it, AI has entered the whole chat. So AI is no longer just a buzzword. It's writing, reviewing, and developing the code. So here, the whole development has accelerated. AI generated bipolar codes is there, and code are there, and then AI is reviewing pull requests. AI is auto fixing vulnerabilities. I've seen multiple tools talking about that. These agentic workflows are there, which are executing these tasks autonomously. So how would you deal with it? There are many tools which are there in the market which are talking about it. So there is explosion in open source and dependency risk as well. So there's a mismatch: AI speed, dev versus legacy security. You can't have code written at AI speed and security done at human speed. Can we do that? No, absolutely no, we cannot do that. So this creates a dangerous imbalance. This creates, or think of, if AppSec remains a bolt on or an afterthought, what will be there? Insecure code, which is shipping faster, vulnerabilities which are scaling exponentially, there are attackers which get more opportunity, and there's digital supply chain issues which are there. And supply chain issues as bombs are something which everyone has started to talk about. I'm glad about it. And instead of catching up, AppSec starts drowning in more code, more vulnerabilities, more dependencies, more exposure, faster release, and less time to review. What will you do? And talk about old security model which simply cannot keep pace with AI accelerated delivery of code which is there, or applications. And think of a developer who is using AI assistant to generate the backend API code. There's no rate limiting, no proper input validation. Debug logs actually leak sensitive information. That can be the case if we don't write it properly. And I am very sure when we talk about prompts, we have issues. And if you ask me to write a code, trust me, I'll have a cold feet. I cannot write a code. But with AI, oh, I am a pro developer. But then comes the point whether am I writing the right amount of code, whether it's in security vulnerabilities. That's something to talk about. So the developers are merging confidently, which is AI generated code. It must be safe. And security later discovers that AI generated code definitely not safe. We've seen this. So this is becoming a daily reality. And back in the day, we were worried about the intern pushing bad code. Now we worry whether the AI intern wrote the bad code and the real intern just clicked merge. And that's when the whole can of worms opens. So the basic thing is that AI, while we take care of all of that, attackers are using AI too. Remember that. And AI is multiplying development or deployment velocity. So this traditional AppSec is still walking, but there's like a speed mismatch and a risk multiplier, what we call it as. And we want to move from code to cloud, where at every step, whether it's design phase, whether it's deployment phase, we want to use AI. And how do we use it? Then comes that these tools are creating or generating risks at every step that you have, whether it's code phase, generating phase, design phase, or any phase. So AI assistants generate a lot of code, but research shows that they often produce insecure code. And even I think since beginning we have been talking about it. For example, study found that 29.5% of Python snippets created by AI assistants have security vulnerabilities. There's a proper paper around it. If you can go to IEEE, there are proper papers around it. Now, because the model is trained on public code, which itself may contain vulnerabilities, those issues propagate. Now, we don't know if there's a right amount of code which is there on the internet, correct? You never know whether it's PHP, Python, what kind of insecure code we have. Now, developers which are using AI assistants or assistant to generate authentication code. Now, the assistant uses a weak default hash or skips input validation because the training set contains such patterns. Here, it is actually now the authentication mechanism itself is weak. What will you do about it? Because we told the AI write production grade code. It whispered back, I assume you mean the latest text or Stack Overflow snippet at 3 a.m. And especially while we talk about vibe coding, it's another big area that needs to be talked about. And it does not stop there. AI model equals to supply chain risks. There's training data, there's pre-training data, or there's a fine-tuning data which is there. Attacks like data poisoning, where adversary or attackers insert malicious or corrupted data into the training set to introduce these vulnerabilities or backdoors into the model output. Then comes attackers which are targeting model supply chains, where the pre-trained models are there. There's open source model repos are there, and then there are third-party dependencies or risks which are there, which becomes even new weak spots. So how do you handle that? So there's a fine-tuned model for code review suggestions, and there's a backdoor which might be backdoored, which you don't even know about it. Now it uses a specific pattern to introduce a subtle security bug or data exfiltration, or not just that, but exfiltrate your secrets as well. What would you do about it? So we used a trusted open source model from the repo, and it turns out it's a secret trigger phrase which is like, oh, I'll give you my all hard-coded credentials, which is again scary. So with AI tools and this whole agentic workflows, I've been hearing about prompt injection. I think everyone talks about prompt injection, but it's not the only problem with these LLM and AI models. But prompt injections become a big vector. Attackers are crafting these inputs that manipulates the behavior of AI dev tools or the models which are there. Here, AI tools may suggest non-existent or malicious libraries, or even outdated vulnerable ones as well. That can be there for sure. There are devs who are blindly adding these suggestions or dependencies which has malicious post-install scripts or even known CVEs or CWEs. So we need to understand that when we are using something, we need to vet it out. We need to use certain tools to check if it's vulnerable or not. Now, let's understand how these AppSec, DevSecOps, and AI DevSecOps is changing. So when we talk about AppSec, which is focused on securing applications through dedicated security activities, whether it's secure coding practices, vulnerability scanning using SAST or DAST, then comes threat modeling, penetration testing, or manual or automated code reviews. That seems like okay, nice, and good to have. So here we are trying to protect the application, but at times at the late stage also, because security is a phase. Now, maybe when we talked about shift left, we started talking about. So traditional AppSec, security teams review what devs have built in. Then come DevSecOps, where dev plus development plus security plus operations. So security is integrated early and continuously across the software development lifecycle that you see here. So here we have these end-to-end security, where we start from the development phase or even the discussion phase, and then we talk about pipelines, which is security integrated into the CI/CD. Then we have automated scanning, which is there, and we have faster time to fix those vulnerabilities. But then we have these shared responsibilities where we have dev plus sec plus ops culture together. So what it says, build plus ship fast. Bake security into all the workflows. Still limited by human scale. So for DevSecOps, we've always talked about security becomes everyone's job, not just at the final stage. Then comes this AI DevSecOps, what it is. And this is actually the next evolution of DevSecOps, where we are leveraging AI ML to make security predictive, proactive, and scalable across these modern developments and AI enhanced workflows. So what's new in that? So here, when we talk about AI DevSecOps, which integrates security for AI generated code, we have agentic workflows. Then we have models which are providing artifacts, whether it's for data, models, or prompts. Then there are tool chains that develop and deploy AI. But what are the capabilities which are there? We have automated security tasks which are there at scale. We are trying to detect vulnerabilities in the AI generated code. We are trying to prioritize based on the risk content which is there. Then we are trying to recommend the fixes in the real time. We're also trying to protect the AI generated supply chain issues, whether it's for models, whether it's for data sets. It's not just for third party dependencies which are there. So we're trying to monitor and govern these AI agents and code execution. So if I talk about AI systems here, they are embedded into the CI/CD to scan, flag, and auto fix code. Plus, we have this infrastructure as code that also comes as a part of it. So here we have continuous intelligent security. So this is something which we need to start looking at and talk about it. So the mindset is something where we want it as speed, security plus intelligence. Here AI is trying to protect AI generated systems. So AI DevSecOps is something where security at machine speed, which we are lacking at the moment. And AI monitors commits, detects insecure AI generated code, auto suggest security alternative which are there, open the pull request, logs the governance or provenance, and passes all those policies and deployments. So if I have to take like AppSec says submit your code, DevSecOps says submit through CI, then AI DevSecOps says don't bother submitting, I already fixed it, tested it, and deployed it. Like that seems so nice, right? But then we still have issues. We've seen these all chaos and challenges which are there. And if I have to give you the stats, Gen AI code has like approximately 40% vulnerability rate. Now, this is not me saying it, but Snyk has done a review, and many organizations have been doing these reviews and finding out there are challenges which are there. And studies show that the AI generated code often lacks secure patterns, input validations, proper authentication, safe crypto. That's there because Gen AI learns from the public code, much of which is like insecure. It may produce working but unsafe solutions, which is there. I think we saw with the Python example also. So a developer, if let's say think about if a developer asks an AI assistant to write an API handler, which if AI returns the code which works perfectly, but then there is no rate limiting, there's missing validation, there's sensitive requests which are being passed. So if that's the case, then there'll be SQL injection, there'll be token leakage, there'll be log scraping which has been there. Do we want it? I don't think so. So that's where the problem comes. And every employee, what they want to do is they want to be an app creator. That's the case. And if you talk about low code, no code, that's something which is like being talked about a lot these days. But then with low code, no code, we're trying to use AI assistants, and which are enabling these non-engineers to build workflows, apps, and automations which are there. So how would you deal with it? So there are product managers, HR, finance, analysts, all can create these shadow apps, and then when they are creating, there are security risks because these employees lack secure coding knowledge, or these apps become vulnerable. So if an HR manager uses an AI tool to build a quick onboarding portal, what will be there? There'll be stores, or there'll be an app which stores employee data without encryption. this. The person might not know everything about encryption. It might be sharing documents from public cloud bucket, or has no authentication separation. If I'll have to give you an example around, like, let's say there's a new portal which this HR team has created around employee salaries. Now they have rolled it out. They've rolled it out, this internal portal for everyone, that okay, they'll see everything there. But now it's powered by AI. So now this person asks that, what should be my salary? Now AI tool comes back and says that, so these the best is that I can be friendly with you, and these are the salary of your colleagues which is there. Now whether to laugh or to cry, if it's less than them, then absolutely person has a problem and share it. And then if it's more, then it's like, oh nice, I'm earning more. But then aren't we sharing the details which are not supposed to be shared? So here you can imagine where things can go wrong. Then comes that most AI generated code focuses on making it work, not making it secure. So there are key security elements which are skipped by default if we don't give the right prompt, which is access control, role-based permissions, secret management, this token scraping, or API protection which is there. Gen AI or AI builds an internal dashboard, but it connects to multiple services using these API keys. Now this is stored directly into the code. And this code, if you look at open API keys on the internet or on GitHub, you will see it everywhere. So then becomes a significant risk. So here we have more AI, but more models, more tools, more agents, more third-party integrations, more shadow apps, and LLM plugins which are there. So every component is new entry point. So think about an AI agent which triggers automated database cleanups. So a prompt injection modified tasks, say delete entire user table, and it runs that query without even validation. What will happen? You can imagine about it. But then there could be data poisoning. I'm like, no, I don't want to delete it, but then I want to poison the data. And then it's not just about data poisoning. There is model extraction, theft, prompt manipulations, unsafe, all those agent actions which are there. So all of this seems challenging, but then comes compliance. Now AI development moves as fast as possible, but then however, there are regulatory controls and internal policy frameworks which are here and there. So what are the common gaps? There are no model SBOMs which are there. SBOMs are software bill of materials where you're tracking everything. There are no audit logs or proper audit logs. This data which is used without the classification, which has been the case, which is the case especially with AI. How would you tag it? Then comes the training data, which is not permissioned or supervised. There's no review of AI generated code. Now then you say, oh, no, I'm taking care of everything. Let me tell you, if you're using AI to generate things, you need to review it at every step. Or there are risks around GDPR, HIPAA, PCI, SOC 2, data residency, or even IP leakage which could be there. So here there are issues with legals as well, and I've seen cases where legal has gone to very, very far. There are risks which are introduced with these pipelines and generated codes as well. So here AI assistants produce code at scale, often very fast without context. So many such code snippets reveal significantly higher incidence of security weakness. And especially if I talk about the black box nature of many AI models, which you may often don't even know what training data they used, what insecure patterns they learned, what their hidden biases or flaws are. I think hallucination is something which I should have called it out early on, that hallucination is there with AI models completely. If you have something which you want to learn and you don't know about, and you ask it, if it does not know as well, it will start creating things. It will start making up things. So here we need to address those things, and especially these pipeline risk or supply chain attacks, and then we need to understand that how can we fix it. And let me tell you, there's another big challenge area where there's more tooling, these more tooling creates more alerts, but without even consolidating triages. And there are organizations with numerous discrete tools which are reporting more incidents. Then comes how do you deal with that? Because there's governance gap which is there. We're still learning these technologies, policies around the AI. So there are no formal policies around any AI tool usage, model provenance, access control to these agent workflows which are there. How would you do that? And not just that, there's a big skill gap which is there. We have to accept it. There are developers which may rely or who may rely on AI assistance, but lack security training because we don't have it at the moment. But we have to evaluate these AI output critically. And I've seen cases where an organization upgraded their CI/CD pipeline to generate or build faster using AI assistant, but weeks later they discovered a trojanized package which has slipped through the cracks. So how do you do that? How do you deal with that? Now your whole code is vulnerable from the get-go. What will you do about it? Either scrap it or start from the very start or from the very scratch. Now it's not just stop there. There are AI agents which are being abused also. Tool that perform code generation, review, and deployment become targets for adversaries, whether it's for prompt injection, model poisoning, or this whole workflows are being poisoned. So how do I deal with it? So there's how to prove security posture, whether it's LLM assurance, model SBOMs, model CVs, because we still don't have it. So how do you take care of those things? So here, when we talk about AI and these risks, AI isn't just changing how software is built. See, we talked about negatives, but we have to talk about positives as well. So here, it's changing who builds it, who secures it, and how security shows up inside the development lifecycle. There are multiple personas that you can create. Even I've created a workshop where I've used Gemini to create multiple personas, multiple people interacting with each other, but securely. And this shift the responsibility across three major groups: security, app creators, and platform engineering. Because here security is creating policies for AI accelerated software teams, where security teams are moving from do the review to define the rules and enforce them through the automation. Here responsibility is where we are defining AI usage, security policies, we are trying to establish governance models, we're setting data handling guardrails, defining model access rules, because there are so many models. Every day I see, oh, there's new model which has come in. For this, there's new model has come in. So here we have to define that what we are using. And then we are approving or securing models and tool providers. And let me tell you, I've seen people talking about, organizations talking about secure by default pattern again. I think that's commendable. Now for app creators, they're consuming policies inside their native AI workflows or workflows which are there. Not just developers, every employee empowered by AI plus low code apps, whether it's analysts, whether it's product managers, marketing, and ops. Now I've been talking about low code as well. This is a complete session in itself. So this groups here which are the platform engineering or the creators, this group implements logic using AI tools without always knowing secure best practices. So they're using AI tools within defined guardrails, they're following security workflows by default, but building apps component with that inherent governance. Here the most important thing is that we have visibility into what code models they're using. That's amazing. Then comes this platform engineering, which is actually implementing these guardrails across AI SDLC. That's the right word, AI SDLC. And if you want to know more about AI SDLC, there's a complete section in OWASP agentic AI ecosystem that's there, and then we can talk about it at length. So here platform engineers are not just offering infra, they are providing secure AI enabled across the SDLC, enforcing policy as a code, hardening the AI pipelines, integrating different security tools, and manage secrets and services accounts. I think that's something to talk about, that yes, we need to do it. Here Now we have AI accelerated development and AI native development. Now what it means is that um, where teams are, so for AI accelerated developments, teams are using Gen AI tools to speed development workflows or traditional workflows, but the underlying SDLC remains the same. The examples like GitHub Copilot generating the code. Then we have ChatGPT, Gemini helping write unit tests, AI suggesting bug fixes. So here we are developing fast, we are reducing repetitive work, we are we are actually trying to lower the barrier for new developers. But there are challenges: AI generated insecure code, lack of visibility, human developers over trusting AI. But then comes AI native development, where applications are designed from day one to integrate models, embeddings, agents, and vector stores. So AI becomes part of the core logic, not just an add-on. So it's become part of everything that we talk about. So here we talk about new product capabilities, adaptive systems, more powerful user experience. But then remember, AI for security helps to test and validate. AI behavior is sometimes non-deterministic, which we need to start working towards using AI human interventions, and then avoid hallucinations. Then talk about the speed, whether it's AI accelerated dev, AI native devs, AI for security, or security for AI. We need to understand that what's at the highest of security lens. So what we need is security for AI. AI has to be part of every ecosystem, every step. We can't deny that. We need to protect the AI stack. As much as we need security, core architecture, defense, we need to have this whole thing secure. We can't just say that, oh, this is the only thing. As much as we say that we have helpers, we have engines, we have analysts, we need to secure our assets, and that becomes very critical to us. Now, being mindful of time, I'm just almost at the end as well. And when we talk about low code, no code, I thought we should have one slide just for that. So with the whole increase in the rise of low code and no code platforms, which are trying to shape the DevSecOps landscape, we want to make sure that we have people knowing what is there and what is not there. Because with AI plus no code or low code, we are shifting the application creation from engineers to everyday business users. So anyone can build apps, everyone becomes a developer. This faster innovation, we are trying to reduce dev backlogs which have been there for ages, and we are trying to democratize the app creation. Anyone can do it. But then security comes into picture. So HR says, I want to create this. Marketing says, I want to do that. Operational says that can we automate these processes independently? And you do it. But security comes into picture. So there's cost efficiency, and then there are risks which are there, absolutely. Shadow IT, and then access controls and issues and improper integrations. But then security comes in and then helps it out. Then comes, there are new tools which are being created, which are needed to address these new threats. So why do we know? Whether it's AI SPM, I love the security posture management words, whether it's AI SPM, CSPM, and whatnot. So there's continuous inventory which is there, but then at the same time, we need policy enforcement. We need to have the policy enforcement for models, prompts, data sets, agents, and all these AI enabled apps. We can't secure what we can't see. So we need to discover all the LLM endpoints and use using these tools, which auto flag that allows these PIIs and prompts or logging issues which are there. So what we need is that we need to understand how much we are using AI assets, how much we are policy compliant, and how much or how fast we are trying to close these violations or the issues. And then comes these red teaming exercises. So there are testings that we can do using these AI agents. So there are unique jailbreak finds which are there. So we can actually we can test it out. So think of it as a refund bot which can be tricked into approving refunds, but then you test it out early on and then it does not do the refund. Then I love using OWASP LLM top 10 testing. So absolutely you can do for model testing. And then the OWASP agentic AI ecosystem is actually helping out with red teaming testing exercise as well, so you should definitely check out. We can also have a central record of each model or agent, which has purpose, data source, fine-tune sets, evaluation results, red team findings, and understand what is overall service level agreement which is there. For that, we need to secure these open source models. We need to do threat modeling for AI agents. Let me tell you, I'm working on these threat modeling for AI agents, and I love it because we need to do it, because we can't just say that, oh, we are using Stride. We need to extend Stride to our agents, tools, and rags, which identify assets, trust boundaries, tool permissions, and escalate all those paths which are there. I think this is totally amazing. And we need to have these AI runtime security, which observes and controls agents' actions in production. And not to miss out on my favorite part, which is MCP with multi-agent security, where we are trying to secure the model context protocol layers, and we are trying to work with the agents which are there. So this multi-agent graphs really helps. All right, now we're almost at the top of the hour. This is what I wanted to share, but we need to have these new tools, technologies, as much as we need it. We need to have it. Like, it's not need to have, it's a must have, so that we understand where things are going wrong. See, when you talk about API keys, there's where you're using. First of all, you need to have proper authentication mechanism for that. My favorite part is where I use just-in-time API keys, where I use it for the purpose and then discard it and rotate it. I think rotation of keys is something which is very important, because you can't go without doing it. Another part is never hard code your secrets in the code, or hard code your keys in the code. That has been a big challenge which is there for many organizations. And if your API keys don't need privileges, why would you give it? So there's one key per app or per service with minimum permissions. That's something which we need to do. And rotation is something which you should do every 60 days, 90 days. You'll be like, oh, this is so fast. Trust me, when we say rotation, it's something which is important, whether it's suspicion because of any kind of leaks. Even there are applications which got breached, and they told their clients that yes, we have got breached and you need to rotate immediately, and those keys were not rotated for years. So that's something which is very important. Another important thing is that we need to automate detection mechanism for API keys, which can scan repos or images or pipelines for any kind of accident leaks. Because now when we talk about AI, there are chances that these API keys might be leaked. So these are some things that we can do it. And best is use a key management system. We use key management service to encrypt or decrypt if we have to actually store locally. So that's something which is important. I won't name any vendor around it, but there are many vendors which are there, which are helping with these key management or secret management systems. So they'll be able to help you out. So use it carefully. Let's put it this way. Understand what you're trying to implement. Because if you want to use a new tool, understand what purpose are you using it for. What are the security issues it might create? Because it's like using something which is meaningful, but at the same time, you can't. Or if I have to give you an example, you can't give keys of your house to a thief, correct? Because you got new doors installed. Or maybe you have a door with the new system which has a passcode in it, and suddenly somebody do the shoulder surfing and they have the keys to your or code to your home system. You can't do that. So you need to understand what purpose is solved. Does it has biometrics? Does it have this? So when you are deploying AI, and because AI is actually advancing at very high pace, so you need to understand that uh, what you're trying to use for. Are you using it for writing code? Then absolutely you need to have the right prompts for it. Then you need, when you, even when you're using the right prompts, you need to have tools which evaluate that yes, these are the security issues in your code. And if your employees are using third party tools like ChatGPT, understand when they're using ChatGPT, are they sharing any internal data that has to be vetted? Or what we have started using it, we are using our own internal GPT. So that's something which has helped us big time. But for what purpose are you trying to use? That's something which is very important. And that's where you can optimize and you can leverage it to the core. That's my 2 cents on it. See, first of all, when you're using these models, you need to have your own measures and keep them up to date. Um, and because if you're using a model, let's say you're using GPT model 3, which is an older model, so will you have a secure model? I don't think so. So you need to secure your data on yourself. So AI, when we are training these models, you need to validate and clean the training data. You need to have you need to remove any kind of secrets when you're training, because there are two perspectives to it in my view. Once, when you're using the model and you're leveraging it and you're training it, so first, when you're using this model, you need to have the updated model itself. You can't have an outdated model which might have security flaws, or which might have an old data, or something which is not good. So it has to be up to date. That's where it starts. Then comes the training of it, whether it's pre-training, post-training, and then fine-tuning. All these things which has to be there properly. So we need to use these sign models which have proper 6 doors, understand what we are using. We need to maintain this model SBOMs. I'm always a big follower of SBOMs, where you maintain what is the version, what are the dependencies you're using, how you're using, so that you can manage and understand where it could go wrong. And these signed models will help us verify the model integrity before even deploying. So these versions, controls, this really helps. Then we can use for this whole pipeline, we can have these approved registries or artifacts which are there. And not to miss, have proper role-based access control. Who needs to have access? If you don't need to have access to the model, you will not be given access. We need to go by these least privileged service accounts. We can't just give every access to it, and test it out for all the test cases which are there, whether it's for fine tuning, whether it's for any adversarial input, whether it's for abuse. All those things have to be done. And rate limiting is something which is the key, absolutely has to be there. But then there are a ton of things that can be done from the model perspective as well. See, if I have to give you in one word, have proper validation, input validation. That's where it starts. But when it comes to securing from prompt injection or model, all those things, there's a session in itself. I've given a session on OWASP top 10 for LLM. I think that's where you should look at it, because if I start answering that needs a session in itself. So you can actually take a look at my session on OWASP top 10 for LLM, and it'll help you out. AI is like, or LLMs are like parrots. They remember everything. So train it right. Make sure when you're leveraging AI tools or LLM tools, only share the information which you should think should be known to public, not everything, because it sounds cool.